Okay, so day 3 out of 4 for the MATLAB tutorial. So we're going to continue looking at some scripts and additional programming language constructs after seeing if statements and for loops last time. Okay. So there's lots of programming languages that have if statements and for loops. And then another construct that many programming languages have, and MATLAB also has, is a while statement. So my next example, we'll look at one of those. Oh, there's my diary. Okay. So what the script does is it chooses a random number, random integer ranging from 1 to 10, and then the user is prompted to enter an integer from 1 to 10. And so the user is prompted to guess what random number has been chosen. So as long as the user does not guess the number correctly, they'll be prompted for another guess. And eventually, when the user guesses the number correctly, then the process stops, and the user will be informed that they guessed correctly. So before I get into the details of this code, I'll go ahead and run it from a prompt so you can see what it does, and then I'll explain how it does it. Okay, so let's type its name minus the extension. Okay, so I'll just go ahead and choose something. That was wrong, so I'll try something else. And keep going. Not having much luck here. Thankfully, there's a maximum number of times this can run. Wow. Oh. We're running out of options here. Okay. So it only took 8 tries. I only had 2 options left, 4 and 10. Well, I did want to demonstrate it because it wouldn't have been good if I guessed it right the first time, because you wouldn't see the iteration. Okay. So what's going on behind the scenes? So first I'm calling ran, and as we know, ran chooses a number between in the open interval 0 to 1. So then I multiply it by 10, so that would give me something, a real number, uniformly distributed between 0 and 10. But I want an integer, and I want it to be a positive integer. So only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for that purpose, I use the ceil function, short for ceiling. So the ceiling function, that takes a number, whatever number you give it, and rounds it up to the nearest integer that's greater than or equal to the argument that has been given. So for instance, if I got a random number that was very close to 0, and then even after multiplying by 10, it's still close to 0, then ceil would just round it up to 1. And because random number has to be less than 1, therefore this number is less than 10, no matter how close it is, it'll be rounded up to 10. So I'll definitely get something in the range 1 through 10. Okay.
Professor, you can use a rand I function directly.
Yes, you can.
Yes.
Yeah. So this is another function that can be used. Okay. So this is a function that generates random integers. So for instance, if I did rand I 10, So the first argument is the upper bound that you would choose. And then the subsequent arguments indicate how many of those numbers you want. Do you want it as a matrix or a vector or some array of how many dimensions? So all arguments that refer specify the dimensions of the returned output of random integers in that range. So in this case, I only want one random number, so I would do rand I 10, 1, and that would do the job. So I could keep doing that to get numbers in the range that I like. I think when I first wrote this code a long time ago, I had never used rand I. So, yeah. Okay. But at least it's a chance for me to talk about the ceil function, because there's ceil and there's floor. So floor rounds down, and then there's round, that simply rounds to the nearest. And I'll talk more about rounding when we get to chapter 2. All right. Okay, so then I display this message that there's that the program has chosen a number between one, let me correct that, 1 and 10. Okay. And then prompting a user for a guess. So that's stored in the variable guess using the input function. So now, here's my while loop. So the way while loop is set up, we have a keyword while, and then here you have a condition, a conditional expression that's evaluated to be true or false. And it can be as complex a condition as you like using operators such as and or. In this case, we're just checking, is the number that was chosen equal to the guess or not? So as long as the condition here is true, then the loop will run. So if I guess the number correctly immediately, then this condition will be false, because we're checking for it being not equal, and then the loop would never run, and it would sort of tell me that I guessed right. As long as it's not equal, then the body of the loop will execute. So it will, so just this statement, prompting for yet another guess. So this value will overwrite the previous value of guess, and control will pass back to the top of the loop, where this condition will be evaluated again, using the latest value of guess. And this keeps going until they're equal, and if I'm being stupid about it and just entering wrong numbers over and over again, this loop theoretically could go on forever. But when they finally are equal, then control passes to the first statement after the while statement, after the end, where we display this message that the user finally guessed right after many tries. All right. Now, well, so first, any questions about the code that we see here? All right. Now, if I go back to the prompt, okay, I'm going to use CLC is for clearing, like it's short for clear console. It'll clear this command window. At least everything that you see here is already in the diary. Okay. So now suppose I go ahead and run it again. And now I'm going to try something different here. It wants a number between 1 and 10, but I certainly don't have to give that. But let's see what happens if I type in some text. Okay, so it didn't like that, so it gives us an error message. This is interesting. Okay, because it says undefined function or variable law. And so what that would mean is, it's trying to resolve what this name means. It's treating what I typed here as if it was a MATLAB command I typed in the prompt, because if you just simply type a variable name in the prompt, what MATLAB's going to do is try to figure out what the variable is, look up its value. And in this case, it couldn't do that. Now, I have a few variables here, guess, number, and x. I'll just go ahead and type one of them in and see what happens. Okay. It did not give an error message. It just said that it was wrong. I'm going to try typing in number. Now, number is it's chosen.
Is the answer.
Yeah. That's why I did it, to get out of this crazy loop. So the thing is, this code is not designed to handle erroneous input, like this blah that I typed here. So this is, ideally, it should handle invalid input more gracefully than this. So what we could do, we can actually modify the code to protect ourselves against erroneous output. That's why I have this additional statement, line 5 here, it's commented out. So now I'm going to bring that in. So I'm going to put a percent sign here to comment out this line that I had before, and then remove a percent sign so that this line is now uncommented and being used instead. Okay. So what am I doing here? Now I have a more complicated condition. I'm still checking whether the number is equal to the guess or not, but I'm checking a couple other things first before I do that. So first, I want the input to have only one element. Because what I could have done, I could have typed a matrix at the prompt. Same way I've typed a matrix at the prompt before to create it. But I don't want that. I want one element. That way a matrix or vector would not be allowed. If that's true, then I go to my next condition. I want my guess to be numeric. So if I typed in some text like I just did earlier, that would not be allowed. So at this point, I know that the user has typed in just one number, and now I can compare that to the guess. So now if I go ahead and try that, I'll type in whatever. Okay, why this is not working like I wanted to? Okay, sorry, this is embarrassing. I'll try something else first. Here I'm giving a vector. And here it handles it correctly, says that it's wrong. So try again. So at least it handles that properly. That should at least be that data. Now here's something else I can try. I'm putting it in quotes. It handled that correctly too. Reason why is word text in quotes is as a valid MATLAB expression, a character string. Now it's declared wrong as far as the loop is concerned because I'm checking for data to be numeric, and since this is not, then it simply says that this condition is numeric. Is numeric will be, value of this condition will be false. It's negated, therefore making it true. Therefore, it will prompt me for another guess. So I've shown you input that would trigger these. Okay. But I guess so if we take a look at the help page for the input function, okay, you might have noticed earlier here it said number being 5. So I went ahead and typed in 5, and it's wrong. 3 turned out to be the correct value. When it was showing 5 earlier, that was a previous value of number from the last time this was run. So while this is running, it will not update the values over here. I just saw a question in the chat. Okay. Okay, when it recognized the guess, we wrote the number, verified within quotes, like 1 in quotes. No, it would not. It would simply, if I take, the word to, TWO, put that in quotes, it's not going to automatically convert that to be, to recognize it as the numeric value 2. So that will not work. Right. I'm going to look at I should mention that there was one function that I showed you last time that was useful for converting values, num to string. So this is meant to convert the other way, take a numeric value and convert it to text for inclusion in a string. And there's some related functions here, but there is no function that goes the other way. Now, if I look at inputs, so we see what it does here. I'm going to make it a little bigger. Okay. So this function waits for input from a keyboard and evaluates any expressions in the input and returns a value and result. So whatever you type in response to prompt, it's going to evaluate that, and then whatever happens from whatever value comes from that evaluation is stored in result. Okay. Now, here's something I can do though. If I call the input function and add this additional argument with s in quotes, then it will not evaluate it. So let's see what that does. I'll try here to prompt. Okay. So I'll type some nonsensical term here, and it will return as a text string. So I did not get an error message like I did the last time. On the other hand, if I do it again, and I enter a number, notice it still treats it as text, which is not really what we would want. We prefer to have the numeric value too, and, instead of a string that's equal to. That has 2 as text. I've also looked at the help page for a function I used in this code. I also used isNumeric to test whether the yes actually has numeric data. Notice there are several other related functions to check if, the type of whatever expression you have. So these can be useful in various situations. Questions up at this point? All right. Now the next function we're looking at, also using a while loop, uses a method that I'll be covering near the end of the semester, Newton's method. So Newton's method is used to find the root of a function. I solve the equation f of x equals 0 for a given function f. The way of using it here is to compute the square root of 2. So I'm applying Newton's method to a function f of x equals x squared minus 2 to obtain the square root of 2. So the way Newton's method works is you have to supply an initial guess. So in this case, as long as my initial guess is positive, the iteration that I have here will converge to a positive square root of 2. If I choose a negative value, it'll be the negative square root of 2. So I go ahead and put out this statement that this is what's going to happen. And now I have a loop here that is set up to be an infinite loop, because the while loop will run as long as the condition given is true. Well, the true is always going to be true. So this loop, the way it's written, will run forever. Or so it seems. So what I do is, this is the main step of a loop. I have my previous guess of a square root of 2, and here I update it. This is where Newton's method comes into play. So Newton's method applied to the function x squared minus 2 results in this iteration that computes the new x from the old x. Now I save the old x before I compute the new one. And then I print out the new one. I'm using the new guess, the old guess, to check whether I should stop. So if the difference between consecutive x's is very small, so less than 10 to the minus 15 times the size of x, then I use this statement, break. A break statement will immediately exit the loop that encloses it, and that's this while statement here. So this loop does not actually run forever. Once this condition is true, then the loop will end. Then I go ahead and display the value that I obtained. And then I go ahead and square it to verify that it's equal to 2. I should mention here I've written 10 raised to the power minus 15, although I don't have to write it this way. I can write it this way, 1e minus 15. This is how you can specify powers of 10. Multiply a number by, so positive or negative. So I go ahead and run this code. See what it does. So the initial guess was 1. Then it was 1.5, and then it keeps going. Actually, I'm going to use format long to show more decimal places. Run it again. All right, now we can see more. If you look at the value that it converts to, you see that the iterates approach that value very rapidly. So here we have, at this point we don't have any decimal places correct. Here we have 2 correct. Then here we have 5 decimal places. And then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places correct. And then it converges. The number of correct decimal places roughly doubles from one iteration to the next. That's called quadratic convergence, which we'll get into when we get to chapter 10. So here, it prints out all the iterates. We see it doesn't take very long to converge. 1, 2, 3, 4, 5. Basically, 5 iterations is all it took. Here, the last 2 values are so close to each other that led to the break statement being executed and the loop terminates. So here's the final value that it obtained. And we go ahead and square it, and we see that it is extremely close to 2. There is a little bit of round off error, but not much. For questions about what this code did. I wouldn't actually recommend using an infinite loop like this. I've used it on various occasions when convenient, but only if I am certain that at some point the loop is going to terminate. It can be proven that this iteration is going to converge. So I felt safe using it here. But I've actually, 2 of the homework problems that I've assigned involve modifications of this code so that it does not use an infinite loop. Okay, I got a question in the chat. Was the initial iterate arbitrary? Yes. So I just, knowing that the square root of 2 is 1.414, etc., I just arbitrarily chose 1. So it can be proven that if I choose any positive value for the initial guess, that this iteration will converge to a positive square root of 2. If I choose the initial guess to be negative, it'll converge to the negative square root of 2. Choosing 0 is not a good idea because you can see here, we divide by 0. Newton's method is, one of the drawbacks of Newton's method is not always reliable. But in this case, when you have a function of constant concavity, so this x squared minus 2 is always concave up, then it works quite well, even if the initial guess is nowhere near. So if I chose the initial guess, actually, I'll try this now. I'm going to set the initial guess to 1,000, and let's see what happens. Still converged. Took a while. Notice that the first iterates were obtained approximately by cutting a previous iterate in half. They started at 1,000. This is roughly 500, 250, 125. And it's easy to see why that happens, because here we have this term, x equals x over 2, and then we add on 1 over x. But if x is already large, that term is going to be small. So we see this repeated approximate halving until we get close to the actual value. So we see that it took many more iterates to converge, but it still got there. Let's see. Okay. Other questions? Now we take a look at, so we can actually access the value of x here, because this is what I ran as a script, so we can see the value of x right here. So as a measure of error, I'm going to take x and square it, and then subtract 2. I'll take the absolute value. So let's see what the deviation actually is. So this is quite small, so in the order of 10 to the minus 16. Actually, this is roughly equal to, it's 2 to the minus 51st power. So learned about floating point numbers and which are significant digits, and then the exponent is multiplied by to describe magnitude. The smallest significant bit refers to the least significant bit corresponds to 2 to the minus 52, so a little bit smaller than this. Okay. One other thing I want to point out about this script is I have some comments here up top that describe what the script does. So if I were to type at the prompt, help Newton's square root, it'll actually read those comments from a file and display that as if it's a help page. So if you add helpful documentation to your code as comments at the top of the file, then that will double as a help page. If you look at the MATLAB's own M files, you'll see that the contents of their help page are written into the M file as comments. So typing help on that command just opens that file and reads those comments. Okay. Notice here, what if I did this? If I put a percent sign here. Now we have 4 consecutive lines of percent signs, and I did it again, then that gets included in the help text, which is not really what I would want. But I want to show you, it looks for, it reads the first several lines that are nothing but comments. Once it comes across a line of code or a blank line, that's when help will stop. Now if I go to do it again, just pull that part. Actually, this is a good time for our break. So, back in roughly 5. Okay. Now, we look at function M files as opposed to scripts. So for that, the first example, one. Convert temp. So the name of a file is converttemp.m. The name of a function is converttemp. So it's the name of a file except for the extension. The way to tell an M file from a script is it begins with a keyword function. That's how MATLAB figures out what kind of M file it is. Now, what follows a keyword function are outputs, if any. A function is not required to have outputs. Here, there's only one output. If there are multiple outputs, as I'll show in the next example, they'd be in square brackets and a comma-separated list. Then an equal sign, then the name of a function, and then any input the function has. And so the list has to be in parentheses, comma-separated list, also like outputs. Now this function only has one input and one output. The input, TF, that is interpreted as temperature in degrees Fahrenheit. The output will be temperature, corresponding temperature in degrees Celsius. So the initial version of a function that we see here, all it does is use a formula for conversion from Fahrenheit to Celsius. So whatever value you have up here, you need to make sure that a value is assigned to it. Otherwise, it'll be an error. So you cannot have an unassigned output, or MATLAB will freak out on you. Okay. So how I call a function, so I use its name and then whatever inputs in parentheses. For example, if I use the boiling point in Fahrenheit, then the output will be the boiling point in Celsius. Another example, the only temperature for which Fahrenheit and Celsius are equal. Now, I want to point out in the code this variable, temp. So we only have 3 variables in this function. We have input tf, output tc, and this variable temp. Now, this variable temp is only known within this function. And to explain what I mean, suppose here's a prompt, I make a variable also named temp. And I just assign a random value to it. Now, if I go ahead and call convert temp to 12, what I'll do is I'm going to make it print out the value of temp that is computed here, so we can all see it. So I go ahead and call this function. So the temperature coming in, subtract 32 from it, and that's the value of temp. And it completes the conversion and outputs 100. Now, I'm back at the prompt, and I'll look at temp again. Have the same value as before. So this variable temp is distinct from this variable temp. They occupy different places in memory. So any variables that are used within a function, those names only have effect through that function. So variables that have the same names but are elsewhere, like defined in this what is called a workspace, or defined in another function, or a script, are separate from variables that are used within a function. So what happens is the value that I provide here as the input, 212, that value is copied to the variable tf in here, and that value is used. Questions so far about how functions work? Now, these operations are performed, subtracting 32, multiplying by 5 times. These operations will be written the same way, no matter whether the temperature data was a number, like I've shown you here, or a vector or matrix. Function will work the same way. So if I make the 2 by 2 matrix, random numbers between 0 and 200, and now I call convert temp on A. So these will be interpreted as a 2 by 2 matrix of Fahrenheit temperatures, and they'll give you a 2 by 2 matrix of Celsius temperatures. In this case, it doesn't matter what type of output is provided, or type of input. Let's try something especially strange. If I pass a character string, let's see what it does. That wasn't expected. Now, what does this mean? I'll show you. I'm going to do it again with just the letter A. And we get that. And now if I pass a temperature, Fahrenheit temperature of 65, same thing. 65 is the ASCII code for an uppercase A. So if you pass a character string, then for the purpose of forming this arithmetic, so subtracting 32 multiplied by 5 nines, the characters are interpreted as integers whose values are ASCII codes. Very strange, but I guess on some level it makes sense. But really, I would prefer that the input is numeric. And here's how I can do that. I'll bring in this if statement. So if the data passed in is not numeric, then I'm going to create an error message. Please provide numeric temperatures. The \n is new line. That's just for appearance's sake. And then this function, error, will cause the function to immediately exit So like when you see an error in MATLAB, this is what's being called, and it'll display this message. So now if I try the same thing, then that's an error. So this is how you can get your code to produce MATLAB-style error messages using the error function. It's really got to make more sense, because it seems strange to interpret this in any numeric way for temperatures. Questions about this one? I have one more example. Number function. Vec angle 2. So what this function does, it takes in the two inputs, x and y, and returns two outputs, angle rad and angle A. So x and y are meant to be two vectors of the same length. So vectors in Rn for some n. This code will compute the angle between those two vectors. And so first it computes the angle in radians, and that will be stored in angle rad. It can also convert it to degrees, and that will be stored in angle day. But the code tries to make sure that the input is valid. So what it does is first uses this function. This is a very convenient function, length. So length, when applied to a vector, will give a number of elements in the vector. So then I can use that to make sure that x and y have the same length. And if they don't, then I will abort with an error message, because whatever follows would fail anyway. If x is a matrix, then what length will do is return the largest non-singleton dimension. So for example, if you have like a 10 by 4 matrix, then length of that matrix would be 10. So now we have two vectors of the same length at this point. So to obtain the angle between vectors, we use this formula, that the dot product of the two vectors is equal to the product of magnitudes times the cosine of the angle between them. So we go ahead and take that dot product. Norm of a vector will compute the Euclidean length, so square root of sum of squares of the elements. So here we have magnitude of x, magnitude of y. And so we divide by the product of those. So this is the cosine of the angle between the vectors. We want the actual angle. So here's the inverse cosine function, a cos, and that will obtain the angle between 0 and pi in radians. Now, here, what I'm doing here is I'm checking how many outputs did the user actually supply when they called this function. N_arg out is the number of output arguments specified when the user calls a function. Similarly, we have N_arg in. That's indicates the number of input arguments that the user supplied. In this case, it ought to be 2. So if the user wants both of these angles, then I go ahead and do a conversion from radians to degrees. If the user supplied only one input, or none, then it does not take the time to perform this computation. There's no need for it. So N_arg in and N_arg out give you a way to customize how your functions behave based on what inputs or outputs the user supplied. There are a lot of MATLAB functions that can be called in many different ways, and the documentation will describe those different ways. So the functions will behave differently based on the inputs or outputs supplied. So it's a way to make functions very flexible instead of having multiple versions of a function that are very similar. So if I make a couple of random vectors, same length, then for this case, I'm calling the function without specifying any outputs. And sure enough, nrgal turns out to be 0. This is the angle in radians. So if no outputs are provided, the first output will be returned and stored in this special variable and that I mentioned to you before. On the other hand, if I specify one output, then nrgal is 1, and here we have the same value stored in the variable anggrad, as you see here. Or I can specify 2 outputs. Angle in degrees. So nrgal is now 2. Here's the angle in radians. Here's the same angle in degrees. Okay. Now, what if I specify too many inputs and outputs? Like if I specify another input here, it'll say too many input arguments. Because in the code, I only have room for 2. It would not know what to do with the third one, so that's an error. Similarly, if I specify an extra output, it won't like, oh, whoops, I'll move that. So here it's not too many output arguments. So you can never go past what's in the code. You can have fewer inputs or outputs. Although in that case, for instance, if I had not specified y, then there would eventually be an error because I make use of both. But MATLAB itself does allow you to specify any number of inputs or outputs less than or equal to what's in the code. It's just then, after that, it's a matter of what the code does. Any questions about what this code does? Notice here we have x transpose times y. So that's how, so x and y are both, well, okay. Actually, here's a situation where this code could fail. I can put a comment in here to that effect. This statement, x transpose y, requires x and y to be column vectors. So in this case, we had x transpose will be a row vector, so a row vector times the column vector will be a number. So here we have, this would be 1 by n, and this would be n by 1. So by the rules of matrix multiplication, the result will be 1 by 1, which is what we want. That's what's called an inner product. Can anyone tell me, what will this expression produce if x and y are row vectors? Yes, it'd be a matrix. That is called an outer product. Now,
There is a dot product function.
Yes. So we have, so this one would, as long as they're the same length, doesn't matter what rows and columns, we can do that. And yes, he mentions here, if A and B are both column vectors, that's the same as A transpose B. So let's put in. Okay. Now we have some time here. Anyone who's made progress on homework 1, I know I've got at least one email, but I still need to answer about that. And I'll do that after class. But questions about anything at this point? Everyone waiting the last minute on homework. I know it's still not due for a while. Well, okay, so it's 13 days away, but fine.
Does the function automatically return those output values?
Oh, okay. All right, yes, what happens is whatever values have been assigned to these variables, those values are automatically returned to the column.
Okay.
So in this case, those values that are in these memory locations, when the function exits, they're copied to these variables here.
Yeah, up until this point, I'm only familiar with C++.
Oh, yeah. Yeah, so it seems kind of weird that yeah, you're accustomed to a return statement. And then Python also has a return statement that can be used to return several values at once. MATLAB does have a return statement, but it serves a different purpose. It's meant to exit a function immediately. So there's no argument to it, it's just return.
Similar to a break.
What?
Similar to a break.
Yes, it's also, so break exits immediately from the enclosing the while or for statement. Return exits immediately from the function in which it appears. All right. Anything more question-wise? This is what happens when I finish early in a class that meets later in the day. Everybody's like, no more. And that goes double for me because, well, normally, not today, but generally, this is my third class in a row. So I have 2:30, 4 o'clock, this one 5:30. So by the time we get to this point, I'm toast. Okay, let's check the chat. Oh, there's something in the chat. Okay, yes, this is a question that I meant to answer by email after class. So similar problems require a file, which could be a script or a function, so those files should be submitted separately. Now, as far as other problems, especially the ones in the beginning where you're typing certain commands at the prompt, if you want, you can do those as a script. I've had people submit like everything in a script, or I've also had people submit separate scripts for each problem or group of problems. So if you use one or more scripts, as long as you use comments to clearly label each problem, that's really all I'm looking for, because then I know exactly what I'm looking at for grading purposes. Yeah. So typical submission. Another thing you can do is if you like, is a diary where it shows the commands you type in the prompt as well as the output that follow them, and that can be helpful because then I can see, oh, okay, your command produced the right output. But if you want, I can do the same thing. I can generate the same thing myself. If you send it to me as a script that can be run, then I can go ahead and run it and have the output that way. So, okay. Yes, you can separate each problem into a section. That's perfectly fine. In this case, are you referring to a live script? I've had some students submit those. Yes, that certainly will be fine. I just realized that what we're seeing here on the screen, because like on my screen now, I'm seeing what you're seeing. Here's those of you who are sitting here, but I also have a chat window up, but you guys can't see that. So I don't know if that will show up in the video afterwards. But if I get a question in the chat, I'll be sure to say what the question is out loud. Now I try not to be too prescriptive when it comes to how homework is submitted. And once in a while, because of that, I may get homework submitted in a format that is not ideal, and I might not really anticipate that. But I'm not going to take off points in that situation. I would either contact the student and ask it to be submitted differently, or I just let it go for that assignment and then say something in class, especially if it's more of a widespread problem, and say, don't do this. Because once in a while that happens, but it's really not my main concern. My main concern is the content correct, and did they follow whatever directions I did give? And for that, it's important to pay close attention to the wording of a problem in a text, because it happens fairly often where the problem might be asking for more than one thing, and some item there is left off. I do check for that, so keep that in mind before you make your final submission, where all items in the question actually addressed. And that goes double for the quizzes in Canvas, the concept check questions, because it happens often where like the last part of the question was not even touched, so don't do that. Okay, we'll go ahead and end the recording here, and of course I'll stick around in case anyone in WebEx or here in the room has questions.